Hi, in this video I'll go through question 1D on map 2019. And here they tell us that the area between the curves y equals x squared plus 2ax plus a and y equals a minus x squared is equal to 9. And they want to know what can a be. Okay, so first I'm going to label these two equations as equations 1 and 2, just so it's easier to refer to them later. And we're dealing with areas and quadratics, so we're probably going to have to integrate at some point. But first, I think it's going to be a good idea to draw out these quadratics and figure out what this area is going to be exactly, just because that's going to help us later when we're trying to figure out what we want to take as our integrals and what our limits are going to be. So let's do 2 first, because I think that's easier. So we've got a minus x squared. So we've got a minus in front of the x squared. So we know our quadratic is going to have this shape. And we have no x to the power of 1 terms. So we know this is going to be symmetric about the y-axis. And also the y-intercept is a. So this quadratic is going to look a bit like this. Let's move it down a bit, actually. And this y-intercept up here is going to be a. And what are its roots going to be? Those will just be plus and minus square root of a. Okay, so we've figured out this quadratic, so now let's look at this one. Okay, so this one has a positive coefficient in front of the x squared, so we know it's going to be this way up. And we can see it also has a y-intercept at a, so presumably the quadratic will look either like this or like this. And the area we want will be this area in between the curves here. So to work out this area, we can see we're going to need to know where the intersection points are. So how can we work those out? Let me move all of this over to the left so that we've got some space to work. Well, to find when the curves intersect, we're going to have to put them equal to each other and then solve for x. So if we tidy this up, we can see we get 2x squared plus 2ax equals 0 because these a's will cancel. Then we can cancel a 2 from this and also factorize an x out to get x times x plus a is equal to 0. And this gives us the roots x equals 0 and x equals minus a. So this intersection point is going to be the one at x equals 0. So this is going to be the one at x equals minus a. So we can see our area is going to depend on the sign of a. So if a is positive, then minus a is negative. So this intersection will be to the left of the y-axis, like it is here. And if a is negative, then minus a will be positive. So this intersection point will be to the right of the y-axis, and the area will look like this. So we can see we've got 2 different cases. And to find the area, we're going to have to integrate. So let's just integrate these 2 equations as indefinite integrals first, and then we can put the limits for the different cases in afterwards. So I'm sure we can all integrate a quadratic. So the 2 integrals we get are these, and so I haven't put the constant of integration on because we're going to put limits in later, so it doesn't matter. Okay, so let's deal with our different cases. So I'm going to do the case when a is positive first. So that's when the curve looks like this, just because I prefer working with positive numbers. Okay, so at first it might not look like a very easy integral to find because we have to add bits and take bits away and all the boundaries of the area are curves. But trust me, it's actually quite simple. So we're going to be interested up to this point where they intersect, which is at minus a. And if we look sort of in this area up to minus a and think about what areas integrating these 2 curves will give us and what the signs of those areas are, you'll understand why it's actually quite simple. So if I integrated the orange curve up to a, I would get this area here and also this little sliver here. And this whole section is going to be positive. And this little sliver here is going to be negative. And if I integrate the green curve between 0 and minus a, then we're going to get this little sliver here, and that bit is going to be positive. And we're also going to get this whole section here, and all of that is going to be negative. And first of all, we want this region here, and to get that, we're going to want the whole integral under the orange curve up to this point, take away this little sliver under the green curve. So we're going to want orange integral minus the green integral for this upper portion. And then for this bit underneath here, I'm going to want all of the area under the green curve minus this little sliver here. So this bit is all negative, so we're going to want minus that. So minus green integral, and then we're going to want to take away this little sliver, but that's already negative, so we're going to want to add that. But you see both of these things come to the same thing, which is basically orange minus, orange minus green. So basically the integral that we're going to find, so remember orange is this quadratic number 2 and green is quadratic number 1. So all we need to get this area is to do the integral between 0 and minus a of quadratic number 2 minus the integral between 0 and minus a of quadratic number 1. And if we put in the limits into the expressions we already found for the integral, this is what we get, so subbing in. And then we just simplify all of this, and eventually find that the answer is a third a cubed. Now, when a is less than 0, our green curve will look like this, and this point here is now our minus a, and we see it's exactly the same as before, but our minus a is now positive. So the integral we'll do, like before, is just the integral of 2 minus the integral of 1, but the limits now go 0 up to minus a, so it's the other way around to what was up here. So either you can do all of this again and substitute these in and put the limits in and so on, or there's also this neat fact that when you swap the limits on an integral, it's just the negative of that integral. So having the limit from 0 to minus a is the same as minus the integral from minus a to 0. And this video is already quite long, so I'm not going to go into the whys and wherefores of why this is true. So if you don't trust me, which I hope you do, but if you don't, there are some good explanations on Math Stack Exchange. But we see that this is just the negative of this, so our answer is just going to be the negative of our other case, so we're going to get minus a third a cubed. So either our a is positive and our area is a third a cubed, or our a is negative and our area is minus a third a cubed, and in both cases those areas have to be equal to 9, because that's what the question says. And we want to find a, so now it's just a case of solving these for a. So if we rearrange for a cubed in both cases, these are what we get. And so we get either a cubed is 27 when a is positive, or minus 27 when a is negative. And cube rooting those gives a is 3 or minus 3. So our a can take two values, 3 or minus 3, and we see that's answer B.